Okay, one guy. I just mix everything up. One more day of daily algorithms. Join the Facebook group, subscribe, and give me your thumbs up if you like what we're doing here. So today we're gonna do a lot of problems, but this is the second problem I'll be boasting, and it's the minimum depth of binary tree. So the minimum depth of binary tree is just a regular tree, and you have to calculate what its minimum depth. So what is a minimum depth? Let's take a look here at the diagrams. As always, when we have a tree, let's think about the base case. The base case is when we have no nodes at all. So what is the minimum depth of a tree that has no nodes at all? It's 0, right? Because you have nothing. What about if we had just one node? If you had one node, then the minimum depth is 1. What if you had this structure here? So you have 3 nodes and they're all going to the left. So the answer, from my intuition, I thought it would be 1, because he would go to the right, he would see there is nothing here, and then that would be just this one. That's the minimum. But actually he wants the minimum depth of nodes that exist. So we don't take into account here. So the answer is actually 3. So the minimum depth of branches, let's say, that do in fact exist is 3. And how about this example here? So in this example, you have 2, because you go all the way to the left, you have 3 to the left, 2 to the right. And which one is the minimum of both of them? It's the right one. So this, what I just said, gives you a hint about what we want. What we want is the minimum of whatever we have to the left and whatever we have to the right. So it's very similar to that problem we did a couple of weeks ago, which is the maximum sum of a binary tree. No, actually the depth of a binary tree, but what we're interested here is the minimum. So we go to the left, we go to the right, we recursively call the tree, and then we get the minimum. Okay, so let's look at the code. Since I'm doing a lot of problems, I'm kind of lazy today, so I'm not gonna code it up with you guys. I'm gonna go through the code, but definitely I'll go back to coding everything by the end of when I catch up. So mean depth. So as I said, in the case the tree has no nodes at all, you just return 0, right? I'll jump this one because actually I think this is the more complicated part, and else 1 plus minimum of the depth to the left and depth to the right. So that's exactly what I talk about here, right? So suppose you're the root. So we know this is 1, and then we sum 2. Which one is smaller? The left or the right? So the right is smaller. So we do 1 plus 2, which is 3. So that's the minimum depth of that. Oh, sorry. 1, and it's 2. Because actually this is 1. The left has 1, the right has 1, the left has 2, and then you sum 1 plus 1, it's 2. Oh, this looks super messy. But anyway, so we get the minimum of whatever we get to the left and whatever we go to the right, and and you're gonna do it for every single node as you're going down the tree. So that's why we do it recursively. In case we have one of the nodes either to the left or to the right, which are none, we don't need to calculate the minimum, right? Why not? Because one of them will be 0. So suppose we have this here, this tree is perfect, right? So when I call min depth to the left, he'll go to this branch here, but when he goes to the right, it will be none for the next recursion call. So it's gonna return 0, and we don't have to calculate the minimum. We know we'll just go to the left, this will be 0 and whatever, right? So yeah guys, so this is the minimum depth of a tree. really cool problem, so good to practice also your recursive technique. And next problem is really cool. It's called symmetric tree, and it's a little bit more challenging than this one, but still pretty cool. And you can use stacks or you can use recursion, and it's awesome. So I hope you guys keep watching the video, give me your thumbs up, and fuck yeah. Okay.